Welcome to another Biota recording. I'm Tom Barbalet, and today I have the pleasure of talking with Bruce Damer. Hello, Bruce.
Hello, Tom.
Gosh, it seems like we've been doing these kind of discussions for many years now, and in fact, we probably have. But the big news is that you are coming close to actually concluding, well, the PhD portion at least of the EvoGrid. So, for folks listening in, I wanted to ask you a few questions associated with the EvoGrid, but in particular, I'm interested in John Graham's role. So, he's not a name that we've been introduced to previously in the EvoGrid discussion, so maybe you could start talking about his work with the EvoGrid.
Yeah, John is our knight in shining armor. He's been a friend for 15, 16 years. He works down at Cal IT2 at UC San Diego, which has huge computing facilities, and he stepped in last fall when the DigiBarn version of the EvoGrid was burning out. The machines were burning up, and he built this wonderful cluster of 30 cores to run our experiments, and showing all of the molecular dynamics that we needed to show to get this thesis done.
And in terms of the results that he's been able to gather, I remember the early discussions. In fact, we recorded a Biota Live, I think, when you were deep in the DigiBarn watching the computers get hotter and hotter. But in terms of the more recent results that he's been able to garner, how has this improved your PhD data? And can you talk a little bit about some of the iterative steps that have gone through this particular phase of the EvoGrid?
Yeah, initially, Peter Newman and I wanted to simulate really sophisticated molecular interactions, such as the formation of a membrane or the creation of informational molecules and sort of origin of life things. We found, however, that in the course of a 3-year PhD dissertation and with a minimal budget and minimal resources of all kinds, that was way overstretching what one could do. So what it settled down to is just proving that we can distribute molecular dynamics simulations across the grid, and that we can do bond formation, and that we can do it with what I call the secret sauce, which is really, it's a widely used technique. It's called stochastic hill climbing or hill climbing, where you pick the top performing little simulations and you propagate them into the future. And that we proved, as a result, that you can do this. You can put molecular dynamics across the grid in large numbers of thousands and hundreds of thousands of small simulations, and you can use this hill climbing and end up with a rich molecular soup at the end. And that's sort of a starting point for doing any kind of big scale primordial soup simulations.
It's an interesting methodology, the description associated with hill climbing, and certainly if you look at a variety of examples, I think the social example is probably the easiest. And to a certain extent, you could see existing societies, the ones that I guess evolve or develop initially the best, if such a criteria does exist, kind of continue to propagate, and then you end up with circumstances that we see currently in modern times associated with things like the rise of China, and also historically you've seen this through societies as societies that have previously been on top have then fallen through either too rapid colonization or a wide variety of other factors. And the same exists in various biology examples as well. Do you have some concern in selecting these kind of groups to propagate on, that you may be actually missing some of the lower steps that may create some of the more interesting things in the future? Or do you do a series of point selections with the view that maybe the top one now may lose in the future, and there may be some more interesting things going on with maybe a couple of steps down? Is it picking out single simulations in particular, or is it actually picking out, for want of a better term, a biodiverse series of simulations?
Well, in a future EvoGrid and with sufficient computing resources and technique, one could explore in the search space, if you will, of a rugged fitness landscape. You could explore all kinds of nooks and crannies, hillocks, and Mount Everests. So in a sense, the use of massively parallel distributed grids at home kind of computing could allow you to do this. There's one thing that the EvoGrid is designed to do that perhaps is a little different than most artificial life or life simulation efforts, which is because we're simulating molecular dynamics with tools such as GROMACS, which are used in protein folding, we couldn't have chemists working alongside that will, if we simulate through a hill climb, a cool thing happens, like the formation of a vesicle or a container. We can go back to the chemists and say, well, we zoomed ahead with great presumption, selecting these hill climb paths along the way, but we got a vesicle. Why don't you set up a staged experiment and see if it actually works in molecules? And if you do this thing bit by bit, piece by piece, you're using nature to validate what you're doing. Now, of course, because the chemists are also able to get the vesicle to form, doesn't necessarily mean that that's how vesicles formed in the primordial oceans of the Earth. But it's suggestive that you're not too far. You're not completely deluding yourself. One of the ideas also of the EvoGrid is the cameo effect, where if you can get some little thing to happen in a simulation, cool little thing, just like perhaps the creation of an enzyme and the action of one enzyme, then you can take all these little cameo simulations and put them into a big simulation and feed a large simulation engine that does not only enzyme forming but vesicle formation, and then replicate that in some enormous chemical apparatus that feeds in your enzyme forming algorithm molecularly in your vesicle algorithm, and see if these things self-assemble into protocells.
Returning to an example that your wife Galen provided, the notion of peanut butter sandwiches and making peanut butter sandwiches for children in terms of maintaining their health, and we folk who maintain artificial life simulations don't have the same kind of maternalistic experience, but I have always argued actually that there is almost an element of kind of maternalism in actually creating and maintaining these simulations. As you noted prior to getting on the call, have a small anniversary associated with my simulation this month. And I'm interested in the EvoGrid as it continues on after the PhD. This was certainly a topic that we talked about when I was on location with you early this year, but also it's been an ongoing topic. How do you see the EvoGrid continuing after the PhD?
Well, it's interesting because the continuation of the project, in a sense, any good project whose time has come has to have its own natural pull. And I found that when I was working in the early avatar space, I started some things. I created the first conference. I wrote the first book, but the whole field had an enormous pull behind it. Many people had similar ideas. And it turns out that in Origin of Life or Origin of Life computational endeavors, there's a bubbling up of efforts all over the place. There's Doron Lancet's group in Israel. There's Stuart Kaufman, some very visionary thinking on his part. He's starting a group at CERN in Switzerland. There's groups in the UK. I mean, there's certainly, too numerous to list. And so the concept that I have is I've been traveling around to visit all these people and go to conferences, and I'm going to put forth a book project that will have them all writing about what you might call computational origin of life endeavor, or COOL, as you, Tom, pulled out the acronym from that one. A book could emerge. A book can help define the key questions of this kind of thing. Terminology. From a book can come a workshop, and from a workshop can come a field, if it's time for the field to be born. And I really believe that it is time. So my role in the future and the role of the EvoGrid is an early exemplar of such a system. There are many others. there is a PhD student candidate who's attempting to find a position right now, Miroslav Karpis, who wants to do the next level on the EvoGrid coding, which is just excellent. And I've been invited. I've joined the NASA Astrobiology Center as an associate, and I've been invited to apply for a grant, a small competitive grant, which I definitely will apply for, just to keep the lights on, in a sense, on the project. Maybe even to fund not more coding, but to fund the book and or the workshop.
Can we talk a little bit about Kaufman at CERN? Because I think that's a very interesting fit there, and this is certainly new information. Has that been announced publicly? Have I just missed that?
What happened, Stuart, Dave Deemer got me back together with Stuart, and I've met Stuart on a couple of occasions. In fact, trying to get him up to the Burgess Shale a couple of years ago, against doctor's orders, I think. But Stuart and I got reintroduced by Dave Deemer, and Stuart basically, in reading some of his more recent ideas, he talked about hypopopulated reaction graphs, which means a space or a soup where you have chemical reactions going on, but he described this hypothetical reaction graph as being able to be an experimental framework to look at the ingression of what you might call novelty, or what Mr. McKenna called novelty, but what Stuart Kaufman calls the adjacent possible, that the universe has the property of complexification, of things assembling and more likely stay assembled and stay complex than disassemble, i.e. the back reaction is not as strong as the forward one. Kaufman talks about this as a possible fourth law of thermodynamics, and he talks about ways to, in a sense, if you look at the universe, it's obvious that this is how it's actually happening, but it's never been really characterized or named by science. It's been named by, counterculture visionaries like McKenna and others, and in the New Age more, but never by science. So I sent him the EvoGrid papers and a poster, and he wrote back, "This is what you have built is a hypopopulated reaction graph. It is potentially a space in which we could test these theories of the adjacent possible and the ingression into novelty and the conservation of novelty." So that got me very excited, because in a sense, the EvoGrid can't do the origin of life thing yet, but it could actually serve as an experimental framework for complexity theory to help this great human, this great genius Kaufman, maybe test some of his concepts out.
It is interesting that it's being done at CERN, because certainly what you're describing, I think, is also fundamentally information theory, and former Biota participant and also Noble Ape developer Pedro Ferreira is at CERN. And I've always thought that CERN was ideally suited for these kind of questions, particularly in terms of the supercomputer power that exists there. So it is very interesting that Kaufman is championing that kind of work at CERN, because I think it's ideally suited.
And he convened a meeting back in late May that I was just present on by phone. And there was a lot of discussions. There aren't any resources committed to it, but there's now a group and it's not that it's based at CERN per se, it's just a few people at CERN thought this is a good fit for us, and Stu is basically saying, look, I'm 71 and a half, I'm not going to really drive and lead this thing, so it's got to have legs on its own. But, it was certainly, again, being in the right place at the right time with the right concept, and I guess I'm a kind of surfer of novelty in science and technology, because I often end up in this position, and then you end up really having to paddle hard.
So, interesting times for the EvoGrid. I'm interested actually probably taking a pulse maybe in September, October after the PhD is concluded. Formally, you are going to give the defense of your PhD in mid-July, aren't you?
Yeah, and in fact, incredibly fortunately, right the week before, not the week during, week before my Viva defense, there's the Origins 2011 conference in Montpellier, France, and I had 2 posters accepted. So I'm now getting those printed up, and hopefully they'll be nearby each other so I can surface both. One is about the EvoGrid, and one is about a model for the origin of life, a very naive model that I've been developing and running past people like Dave Deemer for membrane formation over micropores that can create not only vesicles, but vesicles with interesting junk in them. And right now, as we speak, Freeman Dyson is looking it over.
Good.
Freeman, I wrote to him and thanked him for his early advice a couple of years ago on getting me going on the project, and said I had finished the thesis. And he said and he wrote back, I'd like to see it. So I sent the thesis plus this basically dirty garbage bags model. It's very much in the name of Freeman. The idea that under the oceans you can produce lots and lots of little garbage bags full of membrane-attached informational molecules and other contents over and over again as a factory, and that this may have been the mechanism for the origin of the protocell, this dirty garbage bag factory.
It's an interesting problem that we've created here, Bruce, in terms of our various projects, and certainly when I describe the Biota transcripts to people, particularly academics, the point that I make is always that irrespective of whatever is being published, there are folks such as yourself, fundamentally independent scientists that are doing, well, diverse research, but also motivating others to look in various areas. And the documentation associated with this to date has not been particularly good. We talked a little bit about your book project from the EvoGrid. Has that distilled any more since we last spoke about it?
Yeah, and in fact, I'm writing a proposal for Joseph Seckbach that it might possibly be included in the Springer series, and come up with a title which would be Computing Life's Origins, and probably about 8 or 9 contributing authors. And literally, amazingly, I can lift a whole bunch of the stuff from the PhD dissertation as the structure for this book, because I went through all what I thought at the time were the extant issues in simulating at the chemical level and trying to do the emergence thing within that, and then trying to do search within that and selection within that. And I think any attempt to simulate origins of life are forced, because of the von Neumann computing architecture, we're forced into doing this kind of backflip all the time. And as you look out at the other systems that are designed to allow complex emergence in an artificial chemistry, you see the same constrictions and constraints. So I think that the shape of the technology and the shape of the field is emerging. My argument is, and having been to a number of origin of life meetings, is that we're really going to get nowhere with this thing unless we make it into an industrial strength, industrial scale project with large-scale computing and large-scale automated chemical experimentation tied to the computing. That this is really, right now we're kind of splashing around in the pond, in the little warm pond, but we're just not going to do it. The problem is so much larger and harder. It's harder than the Human Genome Project, for example, by order of magnitude. So it has to be an industrial scale process.
That's interesting, because certainly in my own thinking that has always been the value problem fundamentally associated with artificial life, and how we get to the stage where we can explain to industry. And when we talked in earlier this year, it was very much connected to things like cancer research and other practical applications associated with the EvoGrid that could actually get substantial corporate funding potentially. What interests me more is that you mentioned the human genome, and certainly Craig Ventnor, while he hasn't been using the term artificial life recently, has been talking very heavily about his ability through private, what would the term be? Not even academically accessible research advancing greatly. And I think this was a problem that I put to you when we talked at the start of the year as well. In terms of the openness characteristics of the EvoGrid and a wide variety of open source projects, do you think there is a way that this could be changed to be more commercially palatable, or is it just a means of converting those that would be funders that this method is ultimately the best?
That's a very good question, and I think one could say that if you were doing 3D virtual worlds and simulation in the 80s, you needed pretty big, expensive computers. And a lot of people invested a lot in it at the time for all kinds of things like training and, teleoperations and things like that. If you had only waited until, the year 2000, you would then take advantage of these fantastic game cards and 3D game cards, which wouldn't be precisely what you needed, but close enough. And those were paid for by, billions of investment in the massive multiplayer game and single player and consoles. So you got the technology to do all the cool things because the commercial thing went along and gave you the tools. So one could say one way is to wait for PCR to get cheap. Wait for people like David E. Shaw to make Anton into a desktop box. And for molecular dynamics engines to propagate. You're talking 10 to 15 more years, and then just scoop up some of those tools and do your distributed computation with a better MD engine that's built in, with hardware and things like that. You could say that, but it's an awful long time. I'll be in my mid-60s, and I really want to get going on this thing. So, hat in hand to any billionaire that will listen to me, I will go. And so these are the kinds of things that billionaires with spare change and not a lot of, there's not a lot of sort of oversight in terms of, give me so many patents. I just want to do something that I can put my name on that's visionary. And this is truly visionary. At least would give the field a running start. Spaceship One, Paul Allen put in a few million. Paul Allen put a lot into the Allen Array telescope, the SETI telescope here in Northern California, get it going. He does that kind of thing, and these people possibly will. We just have to name the project after them.
It is an interesting problem. I mean, certainly I think about my own development with Noble Ape, in particular the use of it by Apple and Intel, and in particular the stuff that they have generated through that use. And it is a curious reflective point that there is a potential here for the EvoGrid as a thing, perhaps rebranded, as you've noted, to be developed by individuals and entities that are completely removed from your own interests. And I think this is one of the problems that artificial life developers occasionally find themselves in. Have you thought about that at all, at the potential of a Ventnor or other, perhaps Eli Lilly or some pharmaceutical company to take what you've done very much in the public associated with the EvoGrid and to take it to another level, but in a way that is not accessible by you?
Yeah, and in fact, we have neighbors at our place in New Jersey that work for Glaxo, and I can't remember what the rest of the name, GlaxoSmithKline,
SmithKline, yeah.
Frank Harry kind of thing. Anyway, he's one of the heads of research in a whole area. And when I have conversations like this with him, he said, look, if you can do 100,000 to 1 million atom simulations with bond formation and bond breaking and energies and things like that in molecular dynamics, that is qualifiable, i.e. we can do the simulation and then we can go and look at it in nature. We can do it in the test tube and we can go back and forth. You have created something of immeasurable value to the pharmaceutical business, to all of medical science. For example, you could model a phospholipid membrane and the solvents, the water around it. Now that's taking a huge budget to do a big enough piece of membrane. Now you're looking at several 100,000 atoms. But in that small patch of membrane, you could put the proteins across the membrane, the channels, all those kinds of things, and then they could introduce pharmaceuticals into the outside part, and and try to get an idea of how the body or the cellular body will, invert and do its backflips, and whether or not that pharmaceutical is going to find its way into the cell.
To clarify my question a little bit more, it's the issue associated with if you provide a large portion of this, firstly, in the academic domain, and secondly, with open source, you give the ability for these companies to do these things independently of your efforts, which means that in terms of general value, they are extracting the maximum possible value, at least from what is distilled in the academic and the open source components of your ideas, without actually returning any of those elements to you in terms of funding or future development. And I think that's the problem with a lot of these examples, that the ability for an enterprise like GlaxoSmithKline or Lilly to take what already exists, and if they have already internal engines, as I believe they probably do, to generate these kind of projects and this kind of information, then all we are doing basically is feeding these enterprises, and it is a very completely parasitic relationship. I'm interested in your thoughts associated with how you maintain the EvoGrid in terms of these enterprises giving back if they are utilizing these things. And is it the idea really that what you are doing is always providing the next generation of ideas? So what they need to be investing in is really the next generation of ideas that you are providing, while what you were doing 6 months ago exists in open source and in academic publishing.
Yeah, I think you've hit the nail on the head, Tom, that most of the time these visionary, difficult, basic science lives off of the dregs of big industrial and government investment. So if you can stay a thought leader, and Craig Venter certainly must be, but he's got half of his head in business. If you can stay out ahead and constantly prompt the community and say, look, if you can build your engines in these ways, we can do visionary things like investigating the origins of life, and maybe they will put the right screwdrivers in there and the right handles. Or it becomes that you have helped define a field so that within the framework of the field, the commercial people are operating and the research people are operating, and they use similar terminology. And the same thing happened with avatars. Basically, I came into the field and I encouraged the commercial developers to make affordances like instant messaging within worlds and the ability to jump to your location in sort of teleporter to another avatar. And because of that, the commercial platforms got better. And then as a research team, we could do things like Avatars 98, the cyber conference, because the commercial platforms were better. And years down the road, when the academics finally got around to studying virtual worlds, they were pretty darn rich, and there were people building open source worlds spinning off of commercial platforms which were coming and going. So there's this kind of melange and this kind of mess. But out of the mess, you pluck, as long as there's progress. For example, if David E. Shaw and his team say, look, in the Anton superprocessor for molecular dynamics, we saw this 10,000 atom protein fold in a certain way, and then we went into the laboratory with our friends in Bethesda, and we actually got the characteristic folding of that same protein. That's a victory for everyone. It shows that you can have a computer simulation that actually is mirrored in nature, one-to-one. And that's a huge result that everybody can use, and it's kind of an open source result. Now, we can't afford all of that setup, but it's the proof of concept that really helped.
It is an interesting, as you're describing, it is a matter of extracting the value back at every point, irrespective.
It's a two-way street in a way.
Yes. Well, to change not necessarily the theme, but to change the perhaps the starting point almost on its head, I wanted to send a shout out and thanks to a listener of this podcast, Ruben Thomas, who sent an email to the Biota Conversations mailing list a few weeks ago. Ruben is 15, he's taught himself C++, he's interested in chaos, fractals, adaptive and complex systems, and he's interested in creating his own artificial life project with relatively small scale and functionality in around a year. Now, in contrast really to your experience of forming the EvoGrid both in summoning and in actual form, I think Ruben is looking for something smaller and slightly more manageable early on rather than particularly a visionary project. In terms of folks like Ruben, what would you recommend that they start with?
I think that's a perfectly good approach. And in fact, for Ruben, I kind of suggested the bicameral approach. One being get books like The Machinery of Life by David Goodsell and read about how cells work and blow your mind on that. But then go off and build something and experiment, whether it be taking Polyworld and extending it or some of the open source platforms or building something from scratch. But most importantly, study what has been done before, because you don't want to just kind of invent and see the same phenomenon in your platform that has been seen in many other, say, CA platform. You really should try to take a new tack and add something to knowledge.
It is an interesting problem because I think there are so many interesting projects in the artificial life community, and particularly when you look at the surveying of the history. This was a book topic that we had discussed on many previous occasions, I think, Bruce, that it's probably very easy to spend your life, cutting bait as opposed to fishing, associated with the artificial life community. And I think also, just due to the number of projects, I, as you have noted, I would similarly agree that I think people probably should start looking at existing projects, particularly open source projects, because they're a good starting point to at least get a sense of the code and the environments and these kind of things. But perhaps slightly unlike you, I would also encourage him to start just by writing a simple cyclical simulation that did something. I mean, he's talking about creating something in a year. Certainly my experience with Noble Ape, although I had existing software that I'd written that I kind of brought into the project, but it was very much associated with immediate gratification, and even seeing, small monochrome dots moving around a monochrome island, it was at least initially a project that I could start from. And I think that's one of the beauties of artificial life, is that because it's a relatively simple cyclical simulation starting point, that one really can get results almost instantly and then start looking at how we refine the results that we find. So I think surveying the community is probably a good thing, and certainly offline I passed Ruben a couple of documents, a book and a chapter that I'd written in PDF form. But also I would certainly encourage folks like Ruben to actually start writing simple simulations at the same point that they were also surveying the existing simulations. What are your thoughts, Bruce?
Definitely, and there really isn't a substitute to actually getting your hands in and seeing something going on screen and getting a mental shape for the space. I completely agree.
So, Bruce, it's been a pleasure as always chatting with you. I just, before we conclude, I wanted to note that the reason that there haven't been so many Biota recordings recently, well, in part is due to the Biota transcripts, which are the published form of some previous Biota lives, in fact some quite interesting Biota lives, and I have the luxury of actually having too many of them currently, and I'm still trying to finalise what the first volume will look like. The second volume, however, is going to be, potentially exclusively devoted to the EvoGrid. There are some kind of bordering the EvoGrid related discussions that I also wanted to include, but the thing that I like particularly about the format of the second volume is that it is more about a kind of playfulness, about exploring what-if scenarios as opposed to exploring real-world projects. And I think in that regard, probably the flavour will be more in the vein of summoning the EvoGrid, although you will be a substantial participant in this volume. And it's interesting actually looking at your timeframes, because I think you'll probably have no more than 100-odd pages, but certainly that order of text worth reading and going through sometime in a probably September timeframe associated with that particular Biota transcript. So you've got that fun ahead of you, Bruce.
Wonderful. And by the way, for any who are in the Dublin, Ireland area, the day after the Viva defense of the PhD at University College Dublin on the 13th of July 2011, on the 14th, I will be in downtown downtown Dublin at the Cultivate Centre doing a talk at 7 p.m., which will include the EvoGrid and something called the Great Crescendo and how it all fits in with where civilization may or may not be going. In fact, the program moved from London to Dublin, so I went to Dublin in February, which wasn't the best weather, but I was there a couple of years ago. But it's interesting because it's pretty much 3 years to the day that I registered for the PhD program, so it's about what I expected. And by the way, our dear friend Lorenzo Haggerty has been hassling me and bugging me and inspiring me and saying, look, you should create an ebook out of the dissertation. So I might do that. And he's doing a number of ebook publications, as you've done, Tom.
Certainly.
E and print.
Certainly. In fact, it's interesting because a topic that I want to float through future Biota recordings goes back to the games community, because in parallel to all these other things going on, I'm also writing a role-playing game based on some of my earlier writings, and a large portion of that is based in artificial life methodology. And I think what's particularly curious, because the Chris Hecker discussion that you were a part of, also Jeffrey Ventrella was on that call as well, will probably be going in the first volume of Biota transcripts. But I think the games community in particular is a community that there are a number of ends in with the artificial life community, and I think I would like to record more associated with that particular community and how we can work together going into the future.
Sounds good.
Well, Bruce, it's been a pleasure as always. I'm looking forward actually to all the related recordings and other things that will no doubt be coming back with you from your time, all over Europe by the sounds of things. The Origins of Life conference has always been a point where it has given you a great degree of energy, and I'm interested in hearing your stories associated with the one that you're about to attend, because that had inspired you in a variety of different directions when you attended it previously associated with the EvoGrid.
Yeah, and this is a very big meeting. This is 3 meetings in one in Montpellier, France, starting on July the 3rd, July the 4th, and it's really, and the who's who of Origin of Life people, and our opening speaker is a Nobel Prize laureate of 2 years ago who I actually sat next to and helped her with her video files back in 2009 in San Sebastian, and then who knows, now she's a Nobel Prize laureate. It's an amazing thing.
Very good, very good. Well, I'm looking forward to talking to you in probably a month or two's time to see where the EvoGrid is at that point, and no doubt you'll be receiving Biota transcripts and other things from me before then. Always a pleasure, Bruce. I'll talk to you soon. Take care.
Wonderful. Thank you, Tom.
See you.
Cheers.